Here we have a matrix algebra problem. We're given that matrix X equals the inverse of matrix P times matrix A times matrix P, and A cubed equals the identity matrix. Prove that X cubed equals the identity matrix. Here are some useful rules that we'll refer to when we're doing the problem. So we have matrix X equals P inverse times A times P, and we want to prove that X cubed equals the identity matrix. A cubed equals I will be used later in the problem. As we want to prove X cubed equals I, we'll write out the product for X cubed. And we know that X equals P inverse AP, so we basically write that down 3 times. Next, we remove the brackets. So we can do some regrouping. We have P inverse P here and P inverse P here. And we know that P inverse P equals I from the second rule. So basically, this is written down as the identity matrix here. Now we can do some regrouping. We have identity times A here. And using the third rule, we know that AI equals IA, which equals A. So this will become A, shown here. This is A, shown here. And we have A again here. And from our question, we stated that A cubed equals I. So A cubed is replaced with I here. And we just bracket IP, and we know that IP is equal to P using the third rule. And finally, X cubed will be equal to I, because a matrix times its inverse will be equal to the identity matrix. So we've proven that X cubed equals I. Thanks for watching.